3.6, this is day 2. We need to graph this. So you need to go through that checklist, which is actually on this page. Go through the checklist of setting the top equal to 0, factoring everything, number 1. But setting the top equal to 0, the bottom equal to 0, plugging 0 in, finding a horizontal asymptote, plotting all the information, and then making tables or T-charts, one for each side of any vertical asymptote that you have. That's a recap of what we did yesterday, what you guys had to do your homework. So now we're going to put it all together, and we're actually going to plot all of this information onto a graph, find some T-charts, and then graph it. So, can we factor this? So the bottom I think is going to be easier for us. If I wanted to factor the bottom, because a is equal to 1, what do we think that would be? Or what should it be? X and x. So what is it? X minus 2. I think it would be plus 2 minus 1. So x plus 2 minus 1. If you FOIL that back together, it should work out. The top, you're going to have to either factor by grouping, diamond method, whatever you're used to. Basically, what factors of 2 times 4? So factors of 8, that'll give me a 7, right? Because 7's in the middle. I want to break up 7. So negative 8 and 1. It'd be positive 8 and negative 1. So 2x squared plus 8x minus x minus 4. Factor this thing by grouping. I'm going to change colors so we can see. I like to add that sign in the second group so I know that I'm either going to take the whole sign with it or not. What can I take out of the first group? 2x, leaving me with x plus 4. Make sure that you get an x plus 4 in the second group. Take out a negative 1. So my side work leads us to the result of what? 2x minus 1 and x plus 4. Notice that maybe in the past I would have finished that factoring here before I put it over here. I'm starting to speed things up, starting to plug things in, using my side work off to the side, nice and neat, so at least I know I got some place to go back and look for it, and then I can carry on here. And this is what we're calling f of x. It's still the same. Now notice that you can't cancel anything. Down the road, yes, there will be some cancellation that can happen. Now we go through our checklist. Find our x-intercepts, right? I'm going to list it. X-intercept. X-intercepts we do by what? How did you guys do this yesterday? Top equals 0. You don't have to do this, but would it be good for you guys to actually put top equals 0? Numerator equals 0? Just so you guys can kind of have something to look back at. And now solve them. Some of those you should be able to do in your head. Actually, both of those, I would think at this level, guys, you should be able to say x is equal to what? And x is equal to what? Negative 4 is the very easy one. And then the other one is, bring the 1 over, becomes positive, divide it by 2, it's 1/2. So we have x-intercepts at 1/2 and negative 4. Now when you go to plot those are points. It's negative 4, comma, 0. And 1/2, comma, 0, right? Because they're x-intercepts. So be very mindful of that. What about a y-intercept? don't know if this was the next one on the list, but we still have to find this anyways. What about this one? How do I find y-intercept again? Plug in 0. Let x equal 0. Options, guys. I can go back to the original problem, or I can use my factorization. Which one's easier? They both work. I think the original, because they're both quadratics, and when you put x is 0 in for these, all the stuff that has x's go away, and you're left with, I can just cover it up, negative 4 divided by negative 2. So you'd have y equals negative 4 over negative 2, which is 2, or 0, comma 2. For the y-intercept, I like to always put that as a point. I mean, I could do that. Like I said, we talked about these ones up here as well as points. For some reason, I like to always default my y-intercept as a point. Just the fact that sometimes when I see y equals 2, my mind sometimes wants to write or graph an actual line at 2 instead of just plotting the point at 2. So you got to kind of be careful where you're putting your information and what it means. Because x equals as well, you know, x equals 4, x equals 1/2, those are vertical lines. What's another one? We have x-intercept, y-intercept, vertical asymptotes. So we have vertical asymptotes. That is the bottom equals 0. And the bottom already factored, so that's nice. I think these ones should go really quick, right? X equals what? Negative 2, and x equals 1. Now, here's the thing. Because those are vertical asymptotes, those are the actual equations. X equals negative 2. X equals 1. The vertical line's at negative 2, 1. And I think one of the last pieces is to find our horizontal slash oblique slash slant asymptote, correct? So I'm going to list it as the horizontal. The degree of the top is what? Degree of 2 on top, degree of 2 on the bottom. So this, in the case back here, is case B. Part B says if the degrees of the top and bottom are the same, I then just take a look at the coefficients. Very nice. So that means it's just y equals 2 over 1, which is just 2. To clean that up, just say y equals 2. So you have a horizontal asymptote at y equals 2. You have vertical asymptotes at negative 2 and 1. We're now to the point where we can graph this, or start to graph it. Plot my information so I can find out where do I make my t-charts. What kind of values am I going to place in it? So we're going to start to make our graph. I may run out of room here. We have a vertical asymptote at negative 2 and at 1. Just knowing this information, how many t-charts should I make? Yes, I should make 3 of them. I'm going to see if I can move the vertical asymptotes over. We also have a horizontal asymptote at y equals 2. Oops, that should be dotted. So it kind of breaks it up into 6 regions, yes? The horizontal asymptote is not going to dictate how many t-charts. I'm not going to make 6 of them. I'm only going to make 3 of them. Because remember, I put in x values and get y values out. So therefore, when I go to make my t-charts now, Actually, I probably should plot my other information before I get into this. We have a x-intercept at 1/2 comma 0 and 1, 2, 3, 4, -4, 0. And we have a y-intercept at 0, 2. Wait a minute. We have a y-intercept at 2, but what is at 2? The horizontal asymptote. What did I tell you guys about horizontal asymptotes? I was kind of hinting at it yesterday, because we always keep on saying that a definition of an asymptote is something that's never touched or crossed, right? Except close to home. I said there's always exceptions. And so the horizontal ones are the only ones that could ever be crossed or touched. And this will only happen kind of in this, region really close to home. Once I get out to the end behavior, then it will never. Okay? So that means, more than likely, it's got to cross through here. It's going to cross this region. It's kind of interesting. Any other information that we had found? Okay, so now we can make our T-charts. So I've got 3 areas, 3 regions. So I'm going to make 3 T-charts. I'm going to squeeze this one in here. Okay. And what I'm going to do, guys, is I'm going to pick numbers that are close to the asymptotes, the vertical asymptotes, and work myself away from them, in the cases as the ends. And in the middle, I'm going to try to pick values that kind of span the whole thing. Okay? Now look in the middle. We've already got 2 points that we already know. We know in the middle, 1/2 is going to be 0. And we also know that 0 will be a 2. You guys hopefully see that. We all agree with that. So that means I would put one more point in. What's happening at -1? What's happening at this point right here? Is the graph going to fall back down? Or is it going to go up here someplace? Let's fill in our the rest of the x values, and then I'll give you guys time to start to evaluate these. Now, when I go off to the left, my vertical asymptote's at, was this -2? So therefore, I would pick something like -3, -4, -5. -3, -4, -5. We know -4 is 0, so that's kind of nice. And then when I work to the other side, over here, I'm going to pick values, because we got 1, 2, 3, 4. Do these take a little bit of time? Yes. It's taken us a long time to do one problem, but as you guys start to work on these yourself, it'll speed them up. I'll give you guys a couple seconds to fill in the 5, 6 pieces of information we need. So to find any of these points of information, you can put -3 into the original problem if you feel like it, or into your factored form. Sometimes it might be easier to put it into the factored form, because then therefore you'll only have 4 numbers that you would have to multiply and divide together. Versus up here, you might have to do a couple more, adding, subtracting things. So whatever you feel is best. Does anybody have an answer for -3? -7/4? -7/4. Very well, could be. Notice though where it's kind of going. I'm assuming it's on the rise. What about -5 then? Over 28? Yeah. Is it negative or positive? Yeah, that would be the positive, sorry. So this one, sorry, -4 is on this side. That's why it's negative. So 11 over 28. Okay. I'm just going to go with it. No one else is answering to us. -1? -1 is like over 2. It's going to be on the top side of 2 over here. Where's 1? Negative 1, sorry. We're not there yet?
Wait, where are we supposed to plug these in?
Plug them into the original problem or your factored part? 4.5? 4.5? Anybody got 2? 2, 3, or 4? We are saying that this might be 11 over 18, not 11 over 28.
It's 11 over 18.
11 over 18, or just over half, right?
2 is 4.5 and 3 is 3.5.
2 is 4.5. 3 is 3.5. And 4? Yes. 4 is up there? 3.11. Good enough. Okay, let's plot our information now. I'm going to start in the middle because that's the one we have the most information already plotted. Negative 1 is 1, 2, 3, 4, 4.5. So it should be somewhere about there. It's not going to be perfect. I mean, this graph is pretty messy as it is. But remember, we have to stay close to the asymptotes. So that means it's going to start really close down here and kind of do a little switch over. Like you're driving your car. It should be a nice gentle curve there, right? Switching lanes. Or maybe that person's staying within their lane. I'm not sure. So the gentle curve from one side of the asymptote to the other asymptote. Interesting. Let's go to the far left. So we already have negative 4, 0. Negative 3 is a negative 7/4, which is about a little over 1.7. It's about 1.75, yeah? So, give or take, it's somewhere about there. And 11/18. That's just over half. So there's half, be a little bit above it. This one looks like this one actually looks like the one we did yesterday, isn't it? Just normal corner curve, cutting corners. And I'm assuming the other side will be the same thing. Once you start doing these, you start to realize that this gentle curve thing isn't a lot of graphs. When there's more than one vertical asymptote, that's when you start to get some things going on that are a little bit different in the middle. But on the ends, it generally does curve towards, because it has to, curve towards each of those vertical and horizontal asymptotes. 2, 4.5. So about there. 3.5 and 3.11. So as you can see, there's the graph. And we're happy. So I want you guys to graph this one. This is a case 3. The degree of the top is bigger than the degree of the bottom, so therefore you have to do long division. But you still have to go through finding your x-intercepts, y-intercepts, vertical asymptotes, horizontal, which would be oblique in this case, or slant. And then plot it, graph it, make your tables. So we're going to make this one go faster. I'm going to give you guys some time right up front here to work on this so we can work faster through the video as well. So I'm going to roll the video, and here we go. Can I factor the top? Because the bottom's already factored. X and X. What else? Minus 5 plus 1. So, top equals 0, so our x-intercepts. X equals 5. X equals negative 1. Y-intercept. Plugging 0 in, y equals -5 over -3, or the point 0, comma 5/3. Hopefully we all had that. I know a lot of people working on the long division. Next, vertical asymptotes. X minus 3 equals 0. So x equals 3. Horizontal. Top's bigger than bottom. So top bigger than the bottom. So therefore, long division. X squared minus 4x minus 5 divided by x minus 3. Going through the rules, x to get x squared is an x. Multiply it through x minus 3. Oops. It's x squared minus 3x. Not 3 squared, 3x. Cancel them out. What does that become? Negative x minus 5. And get an x to be a negative x. Multiplied by -1. Technically, guys, you could stop right here. Because that's the quotient part, that's not the remainder. I could care less what the remainder is. I'm going to keep going to show you guys that. But you get negative x plus 3, which at the end will give us a negative 8. So you minus 8 over x minus 3. So we have this polynomial with a, that we divided. We have a quotient, remainder. Guys, if I let x get very large, what's going to happen with the 8 over x minus 3? It's going to get smaller and smaller and smaller and smaller and smaller. Eventually, it becomes kind of like 0. It doesn't actually get to 0. But, saying that, this part does not do anything. I could care less what this is. Because the bigger the value of x, the less important it becomes. So actually, y equals x minus 1, which is just the quotient, has the biggest impact on the graph. That right there, y equals x minus 1, is your oblique or slant asymptote. You need to graph that line as your asymptote. So let's graph some stuff. X-intercepts at 5, 1, 2, 3, 4, 5, and at -1. 0, 5/3 there. X equals 3. And y equals x minus 1. If you guys don't know how to graph a line by now, we're in trouble. Starting at -1, going up 1 over 1. So it's going to look something like this. Now granted, you know the scale is not perfect, the spacing here. So this might be slightly different than what you guys have, if your spacing's a little better. Okay, how many T-charts do I need? 2. 2, because there's only one vertical asymptote. One for this side, one for that side. Now I'm just going to throw this out there. I'm assuming we're either going to be here and here, like the vertical angles of each other, or I will be here and here. That's what I propose, because it seemed like when I did any kind of rational functions, I always happened to be in opposite corners, yes? So, make a T-chart for down here, or on the right side, left side. Actually, notice where your points are. I have points on the top left and the bottom right. So we know points at -1, 0, 0, 5/3. Pick a point at like 2. Pick a point at 4, 5, 0. What's going on here? What happens at 2? Two becomes -3 times 3, which is 9, or -9, divided by -1, so it'll be 9. So someplace up here, right? So guess what? There's your graph. I plugged it into the equation. Put 4 in. I like to use this one because 4 minus 5 is -1, plus 5 is -5, and over 1, so it's -5. And so -5 is down here. And there's a graph. If you guys are graphing that on Desmos, you should see something really close to that. So guys, day 2 is page 322, 31, 40, and 53. I want you guys to graph it like we did in our examples today. Have a great day.